Dear third prep, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Mahmud with you today to introduce a new mathematics lesson. Today, inshallah, we have Unit 1, Lesson 1. The lesson is called Cartesian Product. Inshallah, in this lesson, we are going to remember what the meaning of sets and the operations of sets, and we are going to know the meaning of the Cartesian product. Let's start the lesson. First, we need to remember the meaning of the order pair. The order pair is a bracket included two numbers. The first number called first projection and the second number called second projection, like this. The first number called first projection and the second number called second projection, okay? And usually we use the first number as x and the second number as y, like this, okay? We use the order pair to represent the points on the graph like this. Remember with me, the graph represented x-axis and y-axis. Okay, let we have a point like 3 and 4. Okay, and I need to represent 3 and 4 graphically. 3 is the x coordinate and 4 is y coordinate, okay? So 3 and 4 represented here, starting from 0 to go to 3 and go up to 4. So the point A is 3 and 4, like this. Another example, if we have another point B, 4 and 3, 4 is x coordinate and 3 is y coordinate, okay? To represent B in the graph, we start from 0 and go right 4 steps and go up 3 steps. By looking carefully to the two ordered pairs, we find A 3 and 4, B 4 and 3. Are they equal or not? By looking to the graph, A in a position, B in another, in a different position. So A and B are not equal. So we can conclude this rule, the following rule. If we have x and y order pair equal another order pair 2 and 3. So 2 equal x equal 2 as we see, and y equal 3 as we see. So the first equal the first and the second equal the second as we see. Okay, now let's solve the first example with us. Here in this example, example 1, find the value of A and B in each of the following. First, number 1, A minus 2 and B plus 1 equal 2 and 3. Okay, by looking to the previous rule, as we took before, the first projection equals the first projection and the second projection equals the second projection. So here A minus 2 equal 2 and B plus 1 equal negative 3. So we get two equations. The first equation, A minus 2 equal 2. So by sending 2 to the other side, so 2 plus 2 equal 4. So A equal 4. The other one, B plus 1 equals negative 3. By sending 1 to the other side, so it is equal negative 3 minus 1. So it is equal negative 4 as we see. Another example. Here we have another order pair, A power of 2 and 1, the other side 36 and B to the power of 5. Okay, A power of 1 equal 36. So this is second degree equation. Remember the second degree equation by taking the square root to both sides, and remember, don't forget to write negative or positive like this. So A equal negative or positive 36, which is equal negative or positive 6. The other equation, b power 5 and 1. b power 5 equal 1. To cancel the power 5, then we are going to take the fifth root to both sides. So b equals the fifth root of 1, which is equal 1. Here, because 5 power 5 is an odd power, so we don't need to write negative or positive. We just need to write negative or positive if we have an even power. Okay, another example. Here in this example, number 3, a minus 7 and 26 equal negative 2, b power 3 minus 1. First projection equals the second projection equals the first, and the second equals the second. So a minus 7 equal negative 2. By sending 7 to the other side, positive, so it will be negative 2 plus 7. Okay, so it will be negative 2 plus 7 equal 5. And the other one, b power 3 minus 1 equal 26, like this. So b power 3 minus 1 equal 26. I'm going to send the negative 1 to the right side. It will be b power 3 equal 27, because 26 plus 1 equal 27. Now I'm going to take the cubic root to both sides, and because power 3 is an odd power, so it is just the cubic root without negative or positive, like this. So b equal 3. Finally, we have this example, number 4. An order pair 3 and b equal another order pair 5a minus 1 and 4a. Okay, the first equals the first, so 5a minus 1 equal 3. I'm going to send 1 to the right side, so it will be 4. So 5a equal 4, and now 5a, or 5 times a. Okay, so I'm going to send the 5 to the other side, which is divided. Okay, so it will be 4 over 5. So a equal 4 over 5. Finally, in the other side, here we have b and 4a. b equal 4a, or b equal 4 times a. And here, from the first equation, a equal 4 over 5. So b equal 4 times 4 over 5. This is in place of a. Okay, and so b equal 4 times 4 over 5, which is equal 16 over 5. Now let's study the meaning of the Cartesian product. Okay, before explaining the meaning of the Cartesian product, this is an introduction example. Okay, what is the meaning of the Cartesian product? The Cartesian product means distribute set among another set. Again, distribute set among another set. For example, if we have two sets, A and B, as we see. Set A included dog and cat. Set B included chicken and milk. Okay, so I'm going to distribute this first set among the second set. What does it mean, Mr. Ahmad? It means the dog will need to eat the chicken, like this. This is an order pair represented in the Cartesian diagram, like this. And also the cat needs to drink the milk, so it is represented by an element. Now the dog needs to drink the milk, okay, and the cat need to eat the chicken. So I'm distributed, okay, the first set among the second set, okay, because we have here two elements, and because we have, or two choices, and here we have also two choices, so the result formed from four choices, because 2 times 2 equal 4. Okay, this is an introduction example for the meaning of the Cartesian product, which means, as I said before, distributing set among another set. Okay, now let's study the Cartesian product among the sets of numbers or letters. Okay, the Cartesian product of two sets A times B. Let we have a set A, X for example, equal 1 and 2, and another set Y equal A, B, and C. Here the set X included 2 elements, and the set Y included 3 elements. Okay, I need now to distribute this two elements among these three elements. So 1 distributed with A like this, it will be 1 and 8 written an order inside an ordered pair. And also 1 distributed with B, so it will be 1B, okay, and 1 distributed with C, it will be 1C. Also 2 with A, 2A, 2B, 2C, okay? Here we have, and then I'm going to close the set. So the Cartesian product set x time y or x product y means the set of all order pairs in which the first element in each time belong to x. Here 1, 1, 1, 2, 2, 2 are elements of x. A, B, C are elements of y. Okay, back to the definition. Is a set in which all formed from order pairs, in which each order pair form the first element belong to x and the second element belongs to y. Okay, now I need to calculate the number of elements without making the distribution. How come? Here x included two elements. N means number of elements of x equal 2 elements, and here ny means number of elements of y, which is 3 elements. Okay, to calculate the number of elements of the product without doing making the distribution, so it will be like this: nx times y equal 2, which is the number of elements of x, times 3, which is the number of elements of y, which is equal 6 elements. Okay, now let's study how to represent the Cartesian product. This is called listing method. I have two other methods to represent the Cartesian product. Let's saw these two methods. The first method, or the first representation of the Cartesian product, called arrow diagram. Okay, what is the arrow diagram? From its name, formed from arrows. Okay, for example, if I have x equal 1 and 2, y equal a, b, and c. Okay, first I'm going to draw a rectangle represent the element x. Okay, and another rectangle represents the elements of y, or I can represent both of them in ovals. Okay, now I'm going to use rectangles like this. Rectangle represent x and another rectangle represent y. Okay, here the elements of x are 2 and 1 and 2. The elements of y are a, b, and c, as we see. Okay, and now I'm going to use the arrow. How come? 1 connected with a, 1b, 1c, 2a, 2b, 2c. Here we have 3 arrows from a, 3 arrows from b, so the total is 6 arrows, okay, or 6 elements. Now another representation for the Cartesian product x times y, okay, which called Cartesian diagram. Okay, we used to do the Cartesian diagram, which x-axis and y-axis. Okay, here I'm going to represent the first set x, okay, horizontally like this, okay, and the other set y vertically like this. Okay, x included 1 and 2, so I'm going to write the elements of x, 1 and 2. Y equal a, b, and c, so I'm going to represent the elements of y, a, b, and c, okay, like this. Okay, now I'm going to draw a line opposite to each element. For example, here 1, a line opposite to 1, a line opposite to a, b, and c, like this. And the intersection points represent the elements like this. Here, this is 1a, 1b, 1c, 2a, 2b, 2c, as we see. So this is the intersection points, okay, represent the arrow diagrams, the Cartesian diagram. Now let's study another type of Cartesian product, x2 or x times x. Okay, here if x equal 2, so to represent x power 2, which is equal x times x. Okay, so I'm going to multiply x or distribute x among x like this. Okay, here we have 1 1 1 2 2 1 2 2. So okay, x power 2 or x product x or x distributed among itself equal, okay, the order pair which the set which represent the order pairs like this, x distributed among itself. Okay, now to evaluate the number of elements without doing the distribution, okay, here nx equal 2 elements, so nx power 2 equal 2 power of 2 equal 4 like this. Okay, to represent the Cartesian product x power 2 by arrow diagram and Cartesian diagram, let's see this one. The arrow diagram, as we studied before, here I'm going to write x and the other side x, so here 1 2 1 2 and connect the arrows as I studied before, 1 1 1 2 2 1 2 2, and also by Cartesian diagram, okay, 1 2 1 2 like this. Okay, here 1 1 1 2 2 1 and 2 2. Okay, now because x power 2 is a special case, so also there is another special case for the arrow diagram. How come? Okay, if I have x or if I need to represent x2 by another arrow diagram, it will be like this. I'm going to draw a rectangle, okay, like this. Okay, the other arrow diagram, as I said, I'm going to draw a rectangle like this, and above the rectangle I'm going to write x power 2, or which read as x2 or x times x. Okay, now we have inside x 2 elements, 1 and 2. So I'm going to write 1 and 2 like this, and I'm going to connect the elements by an arrows, but it is circular arrows like this. Okay, here from 1 and 1, this is 1 1, and this is 1 2 2 and 2 2 and 1. Okay, this is the arrow diagram of x2, and this is a special case. Okay, if he asks you in the exam, okay, find the order pair or represented by arrow diagram, it's up to you to use this one or use this one. Okay, but I prefer to use the first one because this is a more simpler than the other one. Okay, now let's solve the next example. In this example, as I took before, x equal 1 and 2, y equals 3, 4 and 5. I need to find the x product y and represent by an arrow diagram and Cartesian diagram. Okay, x product y, okay, we have here 1 3, 1 4, 1 5, 2 3, 2 4, 2 5, like this. Okay, now the arrow diagram. The arrow diagram, I'm going to draw x inside a rectangle and y inside a rectangle like this. X included 1 and 2. Y included 3, 4 and 5. So I'm going to connect the arrows 1 3, 1 4, 1 5, 2 3, 2 4, 2 5. This is the arrow diagram. Okay, we already studied before. Now the Cartesian diagram of the same example. I'm going to draw x in a rectangle like this, and y above in another rectangle like this. Okay, okay, here 1 2 3, 2 4, 2 5, 1 5, 1 4, 1 3. Okay, now I have a remark here. If he asks you to represent x product y, so you have to start with x in the left and y in the right, and also x down and y up. Okay, but if he switch the position, y product x, so you have to start with y in the left, x to the right, and here y down and x up. Okay, you have to read this one carefully. Okay, now another example. Example 2, complete the following. This is a very important example with us. Here, number 1, x equal 3 and so x2 equal. Okay, we need 2. Okay, note that if he asked me x2 or n of x2, there is a big difference between x2 and nx2. x2 means the Cartesian diagram. Okay, so x2 equal x times x, so it is equal 3 like this. And another one, if x equal 1, 2, y equal 3 and 4, so 3 and 4 belong to what? 3 belong to y. And the 4 also belong to y, so 3 and 4 belong to y product y. Okay, another one. nx equal 4, ny equal 2, see, so we need the number of elements, so it will be 4 times 2, which is 8. And here, number 4, nx equal 5, y included 4 and 3, so y equal 2 included 2 elements, so nxy equal 5 times 2, which is equal 10. Okay, here number 5, nx equal 3 and the nx product y equal 12, so ny equal what? 3 times what equal 12, 3 times 4, or here I can find this one by 12 divided 3. Okay, number 6, 3 and 5, okay, belongs to this product, so 3 belong to the first one and the 5 belong to the second one, so x here equal 5. And this is the end of the lesson. I hope it was helpful for you. See you inshallah in the next video. Assalamu alaikum wa rahmatullahi wa barakatuh.